Okay, we've started. The movie is running. Thank you, gentlemen, for sitting down and looking for the iPod. We had an iPod incident, hereby known from now on as the iPod incident. Haley's got extra credit, she found it. Okay, now, you've got to look at the first video in the series for Chapter 13 review in order to really understand this one fully. But there are things that are independent in this video that make sense. And that is simply understanding that pressure, you know, when you learn pressure in the middle school, pressure equals force times area. Okay? Now, I made videos on pressure and derived formulas, etc., and I'm not going to do that here. I'm simply going to state that pressure, P, pressure, okay, equals the gravity, the fact that you're on Earth, times the density. I know that's rho. Usually it's D for density. But it's actually rho. Like the Philadelphia Phillies American baseball team, that's the same letter, okay, rho, okay? And then you have H, which is the height. So, density is dependent upon the fact that you're on Earth, the acceleration due to gravity, on the density of the material involved. Is it salt water or fresh water? Is it air? And then the height of the column. Now, if these two are the same, then it's really dependent upon the height. Let me give you an example, okay? Let's say I have a bathtub that's 1 mile deep, okay? Okay, 1 mile deep. 1.6 kilometers, okay? Is the pressure greater here or here? Where's the pressure greater? In A or B? Is A greater than B, B greater than A, or equal? They are equal. Because it's the same material, right? It's the same material. So really it's dependent upon the height. Isn't the height here the same as the height here? Yeah. Aren't the heights the same? Material's the same. They're both on the same planet. Yes? So it's just the depth. Yes? So it's dependent on these three things. It's dependent on the Earth, the fact that you're on what planet you're on, which is kind of silly sounding, but it's true. It would be different if you were on the moon. The moon has 1/6 the gravity of Earth. It depends on the density. Why is the density important? Well, the density is important because it might be salt water, it might be fresh water, it might be a column of air. So the density is significant. And then it depends on the height of the column. And that's it. Clear? So, let me ask you this. Let me ask you this. What's your weight while you're in water, in the ocean? You're kind of bobbing up and down. Let's say your weight, okay, my weight is 1,000 newtons. That will make more sense if you look at the first video. Mine is 1,000 newtons. That's my weight. We call it FW. That's my weight. Will I weigh that in the ocean? No. Yeah, I'll still weigh that, but what will my apparent weight be? In other words, if you tried to pick me up, what would my weight be? What's my weight? I'm floating. What's my weight? My weight is 0. My weight is, the water is pushing me up. We call that the buoyant force. This force is pushing up, this force is pushing down. When they're equal, well, what's the buoyant force? You've picked a rock up in water, haven't you? Yeah. Isn't it lighter than picking it up in the air? Isn't it? Yeah. Well, do you ever wonder why? You ever wonder why? Like, how do they do that? Like, how? You have this big giant, you have all of this water. Shouldn't the rock weigh more down here if you have this big column and you have all that pressure, right? Okay, so like this rock right here. You ever wonder why that rock It weighs less and you can actually pick it up where you might not be able to pick it up if it were on land. Why does it weigh less? Well, I'll tell you this. You ready for this? This is really cool. This is very cool. Can I erase some of this stuff now?
Yeah.
Okay. I can erase this. Okay. I can erase this. I did that. Okay. It's something called buoyant force. Look up this word. How do you spell buoyant? Look up buoyant. I don't want to spell it. I'm like, look up buoyant.
B-U-O-Y-A-N-T.
B-O-U? B-O-U or B-U-O?
U-O-Y-A-N-T.
A-N-T, good. Excellent. Buoyant, you get it? Buoyant, what is that buoyant force? That's the upward force. What is that? Well, it's going to be the weight. The weight of the volume of fluid, the object, the weight of the fluid the object displaces. Did I spell everything right? I have a problem with letters. Is that okay? Weight, FW, of the volume of fluid the object displaces. Yes? That's a terrible... I should have like a scribe that works for me. I should pay them to write on the board, you know? Letters and numbers I get a little confused. Okay. I'm not crazy, I'm just a little dyslexic, okay? Now, that's what it is. So it's kind of like a weight. It's a force. It's not a weight, it's a force. It's an upward force. Okay? Yes? So if you're floating, if I'm floating, my force equals 1,000 newtons, right? What would my buoyant force be? 1,000 newtons. Yeah. So your apparent weight. So the apparent weight equals your weight in air, okay, minus your buoyant force, right? So what would the weight be of a submarine? The apparent weight that's just moving along in the water at a certain depth. What's the apparent weight? 0, right? Yeah, it's just floating. Yes? Yes? How would you calculate, are you ready for this? Really cool. Are you ready? Right. Big battleship. Aircraft carrier. Enormous. What would the weight of that ship be? So what's the weight? So if you have an aircraft carrier, what's the weight of the aircraft carrier equal to? Look at this equation. The apparent weight equals the weight of the object minus the buoyant force, right?
Yeah.
Yes or no?
Yeah.
So the aircraft carrier is sitting on water. It's floating, right?
Yeah.
Right? It's floating. Like, can you imagine something floating on air? What would its apparent weight be if it was floating on air?
0.
It would be 0. So what's the apparent weight of the aircraft carrier?
It's weight.
No, it's equal to what? You said it. 0. So isn't the apparent weight of the aircraft carrier 0?
Yeah.
Isn't it?
Yeah.
Okay. So I could say that this is 0, right?
Yeah.
All right, you got it? Now, therefore, rearrange the equation. What's the weight of the aircraft carrier therefore equal to? The buoyant force, right? It's equal to the buoyant force. So I can say FW equals FB for floating, right?
Yeah.
Right? So how do you get the buoyant force? What is the buoyant force? It's the what?
The upward.
Yes, it's the upward. I understand that. But practically, what does it mean?
It's the opposite. The weight
of the fluid displaced by the aircraft carrier. So if I put it, let's say, in a giant canal with a lock, right? And I flooded the lock with a known volume of water, but it didn't fill it up all the way. I know the capacity of the lock on a canal. You know what I'm talking about, a lock? And let's say the lock holds 10 units of water, but I only fill it up 4 units, right? How many units is the aircraft carrier?
6.
6 units.
Yeah.
I find the weight of that fluid, and that's the weight of the aircraft carrier. Isn't that great? Isn't that cool? Yes or no? Yes or no?
Yeah.
Yeah. Yes or no?
Yeah.
Yes? Martha? Okay, good. All right, so that ends that. We had some technical difficulties, but we did it. Okay? I'll edit that. Shma. Exactly. I couldn't have said it better myself. Excellent.